Machine learning. You hear that phrase everywhere, right? But what does it actually mean? Let's pull back the curtain and really get into the technology that's quietly shaping, well, pretty much everything.
Okay, so to kick things off, I've got a little secret for you. You are, believe it or not, already an expert user of machine learning. You just might not know it yet. It's working in the background of your life, all day, every day.
I mean, think about it. That spooky moment when Netflix or Spotify recommends something, and you're just like, wow, how did it know? It feels like it's reading your mind, but nope. It's actually a machine learning model that has learned your unique tastes. Or how about this one? You're trying to get a ride home, it's a rainy Friday night, and boom, the price suddenly shoots up. That's Uber's surge pricing. It's a model that predicts, in real time, exactly when demand is highest and more cars are needed on the road. And oh, here's a classic. The spam filter in your email that somehow, against all odds, actually works. It wasn't given some giant pre-written list of spammy words. Instead, it has learned, all on its own, what junk mail looks and sounds like.
And finally, something so simple you probably don't even think about it anymore, your phone unlocking just by seeing your face. That's a really sophisticated machine learning model recognizing your one-of-a-kind features. See, you've been using this stuff all day.
So what's the common thread here? What do all these examples have in common? Well, they all point to this radical new way of teaching computers. It's all about letting them learn for themselves without us having to spell out every single rule. And that brings us right to the heart of it, our core definition. Machine learning is a branch of AI where systems learn patterns from data to make predictions. Now, the most crucial part of that sentence is this: without being explicitly programmed for every scenario. That simple idea, it changes everything.
This chart just illustrates the difference perfectly. You know, with traditional programming, a human programmer writes the rules. You feed in data, you feed in the rules you wrote, and the computer gives you answers. But with machine learning, you completely flip that script. You give the system data and examples of the answers you want, and the system figures out the rules all by itself.
And what's wild is that this huge shift in thinking isn't even new. We're talking all the way back in 1959, when AI pioneer Arthur Samuel had this vision of a computer that could learn to play checkers even better than the person who programmed it. The dream has been around for decades. It's just that now the technology is finally catching up.
Okay, so if machines are learning, how are they actually doing it? Well, it basically boils down to three main teaching methods. Let's dive into the most common one first.
First up is supervised learning, and just like the name suggests, there's the supervisor involved here. We give the machine a huge data set where all the answers are already labeled. It's kind of like studying for a test when you already have the answer key right there next to you. The goal is pretty straightforward. Learn how to connect the questions to the right answers.
Think about it like this. Imagine someone gives you 1,000,000 foreign coins, and your job is to learn how to identify them. Well, they also give you a cheat sheet. Thousands of examples, each with its weight, that's a feature, and the correct currency already written on a little tag, that's the label. After you study enough of these labeled examples, you'd get really good at guessing the currency of any new coin just by feeling its weight. The labeled data was your teacher.
All right, next we have unsupervised learning. Now, this is where things get a bit more mysterious. Here, the machine is given a ton of unlabeled data and has to find hidden patterns or structures all on its own. There is no answer key. It's like being thrown into a massive library with no card catalog and just being told, go organize the books.
So let's try another analogy. Imagine you have this jumbled up list of cricket players, and all you have are two stats for each of them: runs scored and wickets taken. It's just a raw, messy list of numbers. What can you even do with that?
Well, this is where the magic happens. An unsupervised algorithm can look at this massive data and start to see a hidden structure. It automatically groups the players into these distinct clusters. And get this, no one ever told it what a batsman or a bowler is. It just figured out that some players are really good at scoring runs and others are really good at taking wickets. It discovered these categories all by itself.
And our third main type is reinforcement learning. This one is all about learning through trial and error. The machine, which we can call an agent, learns by interacting with its environment. It gets rewards for good actions and penalties for bad ones. Honestly, it's a lot like how you'd train a pet with treats.
A self-driving car is the perfect example here. In a simulation, the car gets a reward, let's say positive points, for staying in its lane, and a penalty or negative points for a mistake like a collision. Now, after doing this over millions and millions of virtual miles, constantly trying to maximize its score, it essentially teaches itself how to drive safely.
So this begs a really important question. If these ideas have been floating around since the 50s, why is machine learning exploding right now? Why is it suddenly everywhere?
It's really a perfect storm of three things happening all at once. First, we have massive amounts of data. Every click, every photo, every purchase creates more raw material for these systems to learn from. You can think of data as the fuel. Second, we have powerful computers. For the first time, we've got the raw horsepower, especially from things like gaming GPUs, to actually process all that data. That's the engine. And finally, we have much, much smarter algorithms. Those are the instructions that tell the engine how to use the fuel. You put all three together, and you get the revolution we're seeing today. And this combination is transforming literally every industry you can think of. In healthcare, it's helping predict diseases and spot tumors on medical scans. In finance, it stops fraud in milliseconds. And in manufacturing, it's even helping invent brand new materials. The real takeaway here is that machine learning isn't just one thing. It's a fundamental technology that's reshaping our world from the ground up.
So this brings us to the future. We've taught machines to see, to understand our language, to find patterns that we could never spot on our own. And that leaves us with one huge question. What do we teach them next?
And this is the thought I really want to leave you with. We now have this incredibly powerful new tool for solving problems. So the question is no longer, can we teach a machine to do something? It's what should we teach it to do next? What's the most important problem you think we should ask it to solve?